Hello there, this is Miss Nakayama, and today's lesson is 10.6, Segment Relationships in Circles. So we're going to use theorems about segments of chords, secants, and tangents. Hopefully you won't think this is too difficult. So hopefully you've looked at the notes and don't have any trouble with this vocab. When two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. Now, we have a tangent segment, and that is a segment that is tangent to the circle at an endpoint. So this is an example of a tangent segment. Then we could have a secant segment, and it's a segment of the chord that contains a chord of the circle and has exactly one endpoint outside of the circle. And the part of the secant segment that is outside the circle is called the external segment. But just like we've talked about before, y'all, a tangent touches a circle in one place, and a secant intersects the circle in two places. So that's why this is a secant, that's a tangent, and we're going to talk about how these are all related to each other and how we can use them to find values inside the circle. So first off, we have segments of chords theorem. And what that tells you is that the product of the parts are equal to each other. So AE, segment AE times EB is equal to DE times CE. Okay, the products, boom, 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 boom. Those are equal to each other. Next, we have segment of secants theorem and segment of secants and tangents theorem. And I'm going to tell you a way to remember this, y'all, that you don't have to actually remember these two separately, okay? So they intersect inside the circle, and we have the products of the parts are equal to each other. All right, these right here where I have two secants or I have a tangent and a secant, okay? I want you to remember this every time you say it, you're going to hear me repeat myself and say this over and over again. But I want you to remember that the outside times the whole thing equals the outside times the whole thing. So when I have this first picture of two secants, the outside external secant, if you want to think about it, external segment of the secant, is EA. So EA times the whole thing is EB is equal to the outside, which is EC, times the whole thing, which is ED. Okay, so it's only this one that has the parts. So outside times the whole thing equals outside times the whole thing. All right, same is true on this one. Outside EA times the whole thing. Well, the whole thing is EA, so it's EA times EA, which is EA squared, equals the outside, which is EC, times the whole thing, which is ED. So that's what you're going to hear me say a lot, and we're going to practice those. All right, these intersect inside. So when it intersects inside, the product of the parts are equal. So I have 6x equals 3 times 4. 6 times x equals 3 times 4. So 6x equals 12 and x equals 2. All right, on the next one, and y'all, if you think this is really easy, go do them and then watch the video and check them while you're doing it. Go do the notes and then check it with the video. That will make it just in your brain that much faster and solidify it. So here I have 3 times x equals 6 times 4. 4 times 6 does not matter. It's multiplication. It's commutative. So 3x equals 24 and x equals 8. Number 3, a little more challenging. So this time I have 2. One part is 2 and the other part is x plus 1. And that equals 3 times 4. So you're going to distribute 2x plus 2 equals 12. And then we're going to subtract 2, 2x equals 10, and divide by 2, x equals 5. All right, number 4 is a little different, but we still have the same concept. The product of the parts are equal, so I'm going to have 4 times x plus 6 equals 5 times x plus 4. I'm going to distribute on each side. 4x plus 24 equals 5x plus 20. I'm going to collect my x's on the right So 1x equals 4. Now, the problem said find AB and PQ. So if I have x equals 4, I plug it into x plus 6, I'm going to have that piece is 10. So the whole thing of AB is 10 plus 4, which is 14. And then if I plug in 4 for this x plus 4, that means that piece is 8, and that makes PQ equal to 8 plus 5, which is 13. Okay? So you just got to pay attention to what's being asked. All right, a few more of these before we move to the other kind. So again, product of the parts. So I'm going to have x times 3x equals 6 times 8. So that's 3x squared equals 48. I'm going to divide by 3. X squared equals 16. Take the square root. X equals plus or minus 4. We've talked about that. It's always plus or minus. Then I'm going to go back and look at my problem and say, can I have a negative 4? Can that length be negative 4? And it cannot. So I throw that one out and I only have x equals 4. Number 6, I have x times 8. I didn't want to do that. Let's try that again. X times 8 minus x. Where'd my x go? There's my x. X times 8 minus x equals 3 times 4. I'm going to distribute 8x minus 8x squared equals 12. All right, this is a quadratic, so we solve that by bringing everything to the same side. Now, because this x squared is negative, I'm going to take everything to the right side. So 0 equals x squared minus 8x minus 12. And guess what? That's supposed to be a plus 12. So make sure you get that down there. That's plus 12. All right, and so then I'm going to factor. That factors to x minus 6, x minus 2. And so that means x equals 6 or x equals 2. So I got to check that. If I put in 6 here, that means that piece is 2, and that would leave that piece to be 6. But if I put in 6, stop. So it can work. It doesn't give me, the whole point is it doesn't give me a negative segment length. So that means both of those are possible answers to this problem. All right, number 7, my pieces are x plus 10 times x. Oh, the x plus 10 is this piece here. X plus 10 times x plus 1 equals x times x plus 13. So remember to FOIL. First is x squared. Outside is x. Inside is 10x. Last is 10 equals x squared plus 13x. So I have my x squareds, but they're actually going to fall out. I don't know if y'all followed that, but if I have an x squared on both sides, they're going to go away. This is 11x right here. So if I take that over to the right, 13 minus 11 is 2. So I'm going to have 10 is equal to 2x. Divide by 2, and x equals 5. And again, check that real quick, and it does not make any of my segments negative, so it's fine, and it works. All right. Now we're down to the last 2 theorems that we had to do, which is the ones with a secant and a tangent, or 2 secants. And the thing that you want to remember is outside times the whole thing equals outside times the whole thing. So when you look at number 8 here, outside is 3, and if outside is 3, then that means the whole thing is 3 plus 9, which is 12. And the other secant, the outside is 4, so the whole thing is 4 plus x. And now I'm going to simplify. So on the left I have 36, and on the right I have 16 plus 4x. So I'm going to subtract my 16, 20 equals 4x, and x equals 5. And that is fine. That works out. No negative values. Number 9, outside is 6. Or my 6. There's my 6. Outside is 6. The whole thing is 6 plus 9, which is 15. The outside is 5. And the whole thing is x plus 5. So 6 times 15 is 90 equals 5x plus 25. Subtract my 25. I have 65 equals 5x and x equals 13. Again, not a problem, no negative segments. All right, number 10, 3. Again, y'all, if you've got it, you should pause my video and try to work these problems and check yourself. It's just going to help you understand it that much better. So number 10, outside is 3. The whole thing is 3 plus x. X plus 3 does not matter. X plus 3, 3 plus x. Outside on the other one is 2. The whole thing is 2 plus 10, which is 12. So 3x plus 9 equals 24. Subtract your 9, 3x equals 15, and then I have x equal to 5. All right, number 11. Outside is 3. The whole thing is x. It's 3 plus x plus 2. Well, that's x plus 5. Outside is 4. The whole thing is 4 plus x minus 1, which is x plus 3. Okay? So don't be fooled. Distribute 3x plus 15 equals 4x plus 12, and that gives me x on the right equal to 3. And we're good. All right, number 12. Oops. Number 12. Outside is x. Outside is 8. I don't know where the x came from. Outside is 8. The whole thing is x plus 3 plus 8, which is x plus 11. The outside is 10. The whole thing is x minus 3 plus 10, which is x plus 7. So 8x plus 88 equals 10x plus 70. I'm going to collect my x's on the right. So my 88 minus 70 is 18 equals 2x, and x equals 9. I have a minus in there. So again, 9 minus 3 equals 6, not a problem. 9 plus 3 is 12, not a problem. All right, number 13. Outside, my outside here is 10. My whole thing is 10. So remember, 10 times 10 is like 10 squared. And then my outside is 5. And my whole thing is 5 plus x, or x plus 5. Okay? So 10 squared. Now, 10 squared is 100. And some of y'all might be asking this earlier. So whenever you're at this original step, when it's all just multiplication, if you know it goes into it, 10 squared is 100. Can I divide by 5 right away? Absolutely. In which case it would say 20 is equal to x plus 5 and x equals 15. But all the other ones I've been multiplying out, but just in case I wanted people to know that you can, like up here, we could have divided both by 5 and gotten rid of it. We could have divided both by 4. It just keeps everything smaller. So it is another way to solve it, and that's fine. All right, number 14, outside is x. And the whole thing is x. So that's x squared equals, the outside is 1, and the whole thing is 1 plus 3. And that's 4. So x squared equals 4. X equals plus or minus 2. But I can't have a segment that's negative, so it's just x equals 2. All right. Number 15. Outside is 5. The whole thing is 5 plus x, or x plus 5. The outside is 7, and the whole thing is 7, so it's 7 squared. So I'm going to have 5x plus 25 equals 49. Subtract my 25, 5x equals 24, and divide by 5, and x equals 24 over 5. Again, not a negative number, not a problem. Number 16, outside is 12. The whole thing is 12. So 12 times 12 is 12 squared. The outside is 10. The whole thing is x plus 10. So I have 144 equals 10x plus 100. Subtract 100, 44 equals 10x. Divide by 10, and x equals 4.4. Not a negative, so we're good. Number 17, outside is x. Whole thing is x, so it's x squared equals, outside is 12. And the whole thing is 12 plus 15, which is 27. So x squared equals, I jumped the gun there. X squared is 12 times 7 is 324. I'm going to take the square root of both sides and remember my plus or minus. I probably should have written that step in there for you. But again, I can't have a negative, and the square root of 324 is 18, so it's x equals 18. Sorry for jumping some steps there. Okay, last, number 18. Again, if y'all haven't figured it out by now, outside times the whole thing equals outside times the whole thing. So in this case, my outside, I happen to start with 3. It does not matter, y'all. So if I start with 3, outside whole thing is 3, so that's 3 squared. Outside is 1, and the whole thing is 1 plus r plus r. And r plus r is 2r, plus 1 is 2r plus 1. So 9 equals 2r plus 1. Subtract 1, 8 equals 2r, and r equals 4. And that is all you have for segments, segment relationships in circles. Really hope you remember outside times the whole thing equals outside times the whole thing, because that's a pretty short way, easy way to remember those theorems. Thank you so much for watching. Please don't hesitate to email me or come see me if you have any questions. Y'all have a great day.